Okay, well, thanks everyone for joining. Good afternoon. My name's Cameron Cronin. I'm the CTO for Accenture's Salesforce Business Group in Europe. And today I think we've got a pretty jam-packed 45 minutes for you. I hope you find it interesting. I definitely do. Having worked in the Salesforce space for a number of years now, it's one of the probably the most important topic that people sometimes kind of skirt around, which is Salesforce security and what does good look like. And I would say it's a timely discussion, but the reality is with security is that when is it not a timely discussion, right? Especially with Salesforce, where the platform is always evolving. And I think I'd say over the last 18 to 24 months, one of the trends that I've seen is that more and more customers have an increased interest in this topic. And there's an increased seriousness in their intent in how that they're approaching security in securing their Salesforce estate. And definitely a large proportion of our teams are working with customers on those types of areas, right? So working with security strategy when we're rolling out projects, more so than we've seen previously as well. But while it's an undeniably important topic, it's a very uncomfortable topic for many. It's something that people don't want to get caught out on, right? But at the same time, it's really hard to determine what's good enough versus what's gold plating. And it's not binary either. There's no place in Salesforce that you can go, check a page, and there's a nice green tick that says you're secure, right? In short, it's complex, it's deeply technical, there's a lot of moving parts, and it's not getting simpler. So to answer the question, really in the first 2 minutes, what does good look like? I think it's understanding the risks, understanding the appropriate tooling, and understanding what that tooling does, because not all tools are built the same. And have a plan to how to mitigate issues early on before they become from an issue or a breach, right? And it's not a point in time activity either. So you need to have a plan that you're reviewing regularly. So I think if you join for that, there you go. You're welcome to drop off, but I would highly recommend sticking around for the other 45 minutes. So joining me today, some speakers from two Salesforce security-focused companies that, in my opinion, are at the forefront of helping customers in Salesforce themselves understand these risks and how to tackle them. So with that, I would like to introduce you to the other speakers today. So Brandon, maybe across to you first.
Hey, great to be here. Thanks everyone for being here. My name is Brendan O'Connor. I am the CEO and co-founder of AppOmni. Before founding AppOmni, I was the security CTO at ServiceNow. And prior to that, I was the chief security officer at Salesforce. I was at Salesforce for about 10 years. So I've been working at the intersection of SaaS and security really full time for the past 13, 14 years. And AppOmni is the leader in cloud security posture management for SaaS.
Great, thanks, Brendan. Across to you, Lorenzo.
Hello, everyone. Lorenzo Farkin here. I'm the CEO and founder of Clayton. I've been working in the Salesforce ecosystem for quite some time. Before starting Clayton, I worked in professional services. I am a CTA class of 2016. So I've been working with this platform at the enterprise level for a while. And this gave me great exposure to some of the things you mentioned, right? And that we are going to discuss today. Thank you for having me.
Great. And last but not least, Aaron.
Hey all, I'm Aaron and I'm a offensive security engineer at AppOmni as part of our newer AppOmni Labs function. And my primary role is to perform security trailblazing from a purple team perspective across all of the different SaaS applications that we support, and Salesforce namely being one of these. It's fantastic to be here. Thank you for having me.
Okay, great. Okay, so before I hand across to these guys, I wanted to kind of take a step back and talk to you a little bit about Salesforce's evolution and an area where we see customers get caught out a little bit. So what you can see here on the left-hand side is the end-to-end solution for Salesforce back in 2010. So for some of those who have been around as long as me in the space, this may look familiar to you. I think that was the same year that Chatter was launched. So things have come a long way since then. So sales and service, which would have been on Classic at the time, which wouldn't have been called Classic then. You've got Siteforce here, which is the predecessor to Communities, and Force.com, which is mind-blowing now. Apex and Visualforce had only been launched a few years prior. Now, you compare this across to the right-hand side. So obviously, their marketing budgets increased quite a bit, and the graphic's quite a lot nicer. But you can see here that the capabilities that the platform has drastically expanded. And a few interesting things here, right? So if you take Visualforce, which I talked about, 10 years ago, when this slide was put together, since then there's been 2 versions of front-end libraries, right? So you've had Lightning components, Lightning Web components. The Apex language from 2010 to now massively changed. So how you write good best practice Apex code, secure code, and test that has changed significantly. And Salesforce has introduced a whole suite of new tools that you can declaratively build out with, and a bunch of critical updates to evolve how the platform's being used. And on top of that as well, industries. So industries also, from the Velocity acquisition, it brings a lot more capability and complexity and customization options for things like OmniScript. Now, all these things are distinct technologies. And what that means is it's great, there's evolution, there's innovation, but they all come with their own security considerations. And these need to be managed, right? And then on top of this as well, don't forget the regulatory landscape has changed significantly as well. So if you think about from a European perspective, you've got GDPR, you've got Schrems 2, and different parts, where you are in the world, there's a whole variety of other regulatory requirements, maybe regional or industry based, that you now need to keep in mind when you're building out your Salesforce solutions. It's a good thing, but it obviously makes our jobs a little bit more complex. And if you look across to the left-hand side here, this is a slide for their investor deck. It's not slowing down anytime soon. And I'd say it's even increasing significantly, right? The pace of change. And we've seen some pretty large acquisitions that Salesforce has made. This only goes to 2010. And I'm sure you can see some of the logos that have been acquired since then, some pretty large names like Slack. So the pace of change here is not slowing down at all. And we're definitely seeing that customers are scaling out horizontally and vertically. So horizontally, you're adding new capabilities, like you might be bringing in portals, you might be doing commerce, bringing B2B commerce or B2C commerce, marketing cloud, and vertically where you're stacking in new technologies. So you might be upgrading your sales or service to incorporate new capabilities that have been released, or you might be customizing it with Apex, Visualforce, Lightning Web components, depending when you started that journey, to add more capability to that. And you've probably seen this increase over the last 24 months of COVID. From our perspective, we've seen basically rocket fuel being thrown on digital transformation programs as customers and consumers are adjusting to the new normal. So the problem here is that what may have been initially a small internal application or maybe a large application for enterprise use cases, you now have potentially partners coming into that org. You may have customers coming into that org. They might be self-serving. They may be transacting, making financial transactions inside your Salesforce org. Yeah. And if you look across to the right-hand side, what you can see here is that Salesforce's numbers support that as well. So what customers are doing in their orgs is that they are scaling out, and you can see here the trend from 40 to 50% of the install base. The revenue is coming from new products being added in. Now, where we see customers get caught out is that they're doing all these great things, but they're not really keeping their security strategy, the tooling, the governance, and the controls and monitoring at the same pace of innovation and evolution. So, what you were doing in 2010 was probably fit for purpose then, but 2021, things have moved on a lot. The applications you'd use, the methods, the best practices, and that's something that it's very hard to keep pace of. And a lot of times customers aren't even aware of these risks, to be honest, or the tools that they could use to mitigate them. And even security folk are not really appropriately equipped in lots of these organizations to deal with it due to the breadth and depth of the platform. So from our experience, what we're seeing is that we're having to create offerings to basically, build security offerings. And we even have SMEs now that are purely security focused, which 5 years ago was like not even a consideration, right? You didn't have that kind of that requirement as much. Okay, so with that, this is probably a good segue to bring you in, Brendan, into the conversation. And it'd be really good to hear from your perspective, from the experience at AppOmni, or where the greatest risks and areas of vulnerability that you're seeing. with the customers that you're working with?
Yeah, thanks so much. So at AppOmni, we offer a 1-hour rapid risk assessment of Salesforce. You can reach out to us. We can connect to a Salesforce environment, scan it and disconnect in an hour or less, showing you the findings. So we can scan API attack surface, suggest configs, look at the permission model very, very quickly. And we have done this hundreds of times for large enterprise customers. So these are not small companies I'm talking about here. About 80% of our customers are public companies. So we're talking about large enterprises that have mature deployments of Salesforce. And these are the findings that we have. We find that 99% of the time, external users are greatly misconfigured relative to what they have access to in the Salesforce environment versus what they should have access to or what the business intended them to be able to see. We find that integration accounts, so API, connected app, or third-party app exchange accounts that are connected into that environment, 95% of the time they're over-provisioned. And I'll say that oftentimes we find third-party integration accounts that have been given modify all data, view all data, manage users, customize application, where you're giving a third-party super user access into the org, and the security team has no visibility into who these vendors are or what privilege level they have. We find that API-based ETL apps, so Workbench, Data Loader Bulk, Force.com tools that allow you to quickly and easily import and export massive amounts of data, we find those are provisioned for all users in about 85% of deployments. So you have these very sensitive data tools that should really only be used for IT and administrators, and everyone in the org can use them. If they know about the tool, they can connect and they're already provisioned or they have that access. We find data exposed to the public internet in 55% of cases. Now, this comes in a variety of different forms, but we find more than half the time an administrator, user, or contractor within that Salesforce environment is accidentally or unintentionally exposed sensitive internal data to the outside world, oftentimes without the need for authentication. They don't even need a username and password sometimes to get at this data. It's been exposed incorrectly. And then we find relative to Salesforce's best practices, and they do a great job of telling you what those best practices are and building these modules on Trailhead. We find that on average, customers are only 65% in compliance with those best practices, 35% are out of compliance. So this is our view looking at hundreds of customers. But right next to it, I have stats from the very recent Verizon data breach report. So the Verizon data breach report came out just a few weeks ago, and it's showing real world incidents and data breaches of large companies that misconfiguration by humans is a leading cause of incidents and data breaches, or the abuse of privileges where users have been given way too much access that they didn't need is a contributing factor in a significant majority of breaches and incidents. So these are not theoretical vulnerabilities. This is how companies have been getting breached and security incidents that we're seeing in the real world over the past year. Next slide.
Great.
Aaron,
Thanks
can
for
you
that,
talk
Brendan.
a little bit about what you're seeing in the real world with your research?
Yeah, absolutely. So for those of you who may not be aware, prior to joining AppOmni, I released an article discussing how an unauthenticated user, categorized in Salesforce as a guest user, can extract record information due to misconfigured permissions by utilizing built-in functionality in the form of Apex controllers within Salesforce. Now, this article was really the first of its kind in which it publicly detailed the process of how a malicious, unauthenticated actor could exploit overly permissive access. And really in doing so, it shed a light on a problem that many organizations didn't necessarily believe existed. So this article had thousands of unique views, and around 50 individuals were reaching out for conversation and sharing their thoughts on the research. And the occupation or background of these individuals could be broken down, for the most part, into 3 categories, as you can see in the slide, with security researchers, which also includes internal security teams, being the largest group. And my takeaway from these interactions was that, well, firstly, security researchers and internal security teams were largely unaware that this type of exploitation was possible, so often leaving Salesforce overlooked in penetration testing engagements. And in addition, the Salesforce administrator group felt that it was actually their responsibility to ensure that permissions were not overly extended to the guest user profiles. So now I'm going to walk through the common sources of these misconfigurations and where they can commonly arise or service themselves within the Salesforce platform itself. Next slide, please, Cameron. So starting from the top, and the most prevalent sources of misconfiguration would be the profiles and permission sets. So profiles have a one-to-many relationship with Salesforce users. And prime examples of profiles, as I previously mentioned, would be the guest user profile or a community portal profile. Now, these are normally used to provide a baseline of permissions for users. In combination with this, though, there's often permission sets, which are used to further extend the permissions available to individual users. And a user could have multiple permission sets assigned to them and only one profile. And this is typically where you begin to see the configuration drift of permissions, making permission management much more difficult, since over time there could be a large number of individual users, each with varying profiles and permission sets. There's also sharing settings. So this is Salesforce's record level security. And these are used to dictate which records of a particular object or custom object are accessible. In the context of the guest user, this is dictated by the default external access of objects as part of the organization-wide default settings. And these are commonly referred to as OWD in the documentation. And Salesforce has really pushed a secure by default model here, ensuring that any Salesforce instance with experienced communities, or also known as Lightning communities, created past the Winter 21 update, I believe, has the secure guest user record access setting enforced. And what this does is it enforces a private sharing setting for all objects, which ensures that by default, they cannot access records that do not belong to them. In combination with the ability to reassign guest user created records to another internal user within the organization, I think in this category, Salesforce has done a really great job of assisting us with securing record access. Community settings, these are applicable if you have a digital experience deployed on your Salesforce platform. And unbeknownst to many people, some of these individual community settings can also dictate object and record access. So although the secure guest user record access is enforced, Salesforce administrators may accidentally grant the view all users permission, for example, indirectly through a seemingly innocuous community setting, which is as easy as just clicking a checkbox and hitting save. Very easy mistake to make, and it's commonly seen. Third-party apps. So in this context, I'm referring to connected apps specifically within Salesforce. And as I've shown here, there's 42 connected apps on average within an org, with 22 no longer used but still have access through tokens, which in some cases belong to privileged accounts within the Salesforce platform. And in addition to this, if many users are pre-authorized by administrators to utilize these third-party apps, it just becomes even more difficult to track access that these apps may have across your organization. And then lastly, there's custom development. And one of the greatest things about Salesforce is that they provide you with the ability to extend their own fantastic built-in functionality and further customize your applications. So this can range from custom functionality implemented through Lightning components, the newer flows and the older Visualforce pages, to custom sources of data, such as custom settings and custom objects. Naturally, custom functionality can introduce additional risk, as secure coding practices are required to be followed in order to do it well. And in the case of custom data sources, it'll also add additional responsibility for permission management. Now, in relation to these top three bubbles, which, as I've mentioned, are really the bread and butter for object, field, and record access within Salesforce, I'll briefly show on the next slide how we help our customers at AppOmni combat the problem of permission management and drift. So next slide, please, Cameron. So here we have a brief screenshot of AppOmni's Access Explorer functionality, which is one of our features within the product. Now, what this allows customers to do is, through our unique impersonation functionality, they can step into the shoes of a particular persona and get a view of their access from their own perspective. So customers leverage this to determine what data, Apex, and third-party apps an individual user within your organization can access. It's quite easy to understand, as you can see in the screenshot. On the left, we have the standard or custom object name and label. And within each row, we have the level of access that this particular user has on the object in relation to Salesforce's permissions. So view all and modify all, etc. And my favorite functionality here is that by hovering over the individual permission, customers actually have the ability to see the source of the assignment. So I'm talking about the exact profile or permission set that gave this user access to the object. Next slide, please, Cameron. So here we have the typical attack entry points for an unauthenticated malicious actor via various publicly facing applications on the Salesforce platform. And on the bottom left-hand side, we have digital experiences known as previously as Lightning Communities, which are the most common and easiest way for organizations to create a public site via the drag and drop experience builder. And the two most common custom implementations on these experiences are Lightning components and, as I mentioned previously, the newer flows. To the right of this, we have a force.com site, which doesn't have a digital experience deployed, but can also rather have a custom Lightning application. And a prime example of a custom Lightning app that I've seen, especially within the past year, are COVID appointment booking applications. And these custom Lightning applications may also contain their own custom components, and in addition, underlying Apex code. And then lastly, there's visual force implementations on force.com sites, which, admittedly it's older, it's less common, but it is still leveraged by organizations today. And visual force pages utilize either JavaScript remoting or visual force remote objects to retrieve data and return it to the user. It's important to note that all of these methods of custom functionality are subject to the same classes of vulnerability because they're relying on the same underlying Apex, even though they may be implemented differently on the front end. So keep in mind that while we have one Lightning community in this diagram, in this example, organizations can have multiple communities. They can have multiple force.com subdomains, and all for different purposes. On the second row, these are the methods of communication between the front end components and the back end. And the different APIs depend on the type of component implemented. So these are public APIs which can be queried by anyone regardless of authentication. That being said, though, the user must have access to the function that they're calling. So in relation to the Aura API, a prime example would be an Aura-enabled Apex method, which the guest users have been explicitly granted access to. And lastly, and really the most exciting, is the underlying Apex for all these custom components. And this contains only the source of the vulnerabilities. Now, Salesforce has introduced secure by default behaviors over the past year or two, such as enforced sharing rules by default when you're creating Apex classes. And this is effectively meaning Apex code running in user mode as opposed to system, and easy to implement access control Apex functions. However, naturally, as always, by organizations taking the quickest approach and not necessarily the most secure approach, these secure coding best practices are not always followed. And as a result, the Apex may leak data from objects or custom settings to unauthorized users. Naturally, this is going to depend on the functionality implemented within the Apex itself. So in relation to what good actually looks like and some brief tips. So organizations should firstly have explicit awareness of the Apex functions that are exposed to these APIs, especially in relation to the public. Secondly, ensuring that code is running in user mode and that access control functionality is implemented always to ensure that permission checks are performed prior to returning any data to the user. I cannot stress this enough. Believe it, there is no shortage of Apex methods that can be leveraged to do this, and Salesforce has done a fantastic job of extensively documenting each of these. And in the case, so an interesting case here with the custom settings is that it's typically used as a form of secret storage, but it's often very misunderstood and as a result not configured correctly. And the primary reason for this is the misconception that configuring a custom setting as a protected custom setting somehow makes it secure by default, and it doesn't. The most secure method of implementing secrets within custom settings would be by placing these custom settings within a managed package that has its own namespace within your organization. So creating that separation between the organization's namespace and the namespace of the package. And within that managed package, you can create a single global Apex entry point to interact with the secret, and you can then ensure that it's only accessible to high privileged users, such as your typical system administrator. So now I've given insight into how custom functionality may be implemented within Salesforce and some ways that they can be misconfigured. So now I'll hand you over to Lorenzo, who will go further by discussing the kinds of vulnerabilities that can result from these poor development practices.
Clayton, we focus on secure development for Salesforce, and we scan hundreds of business applications built by enterprise team on the Salesforce platform. On average, 1 billion lines of code per day, contributed by several hundreds developers. And what our data shows is that vulnerabilities are in fact common. 60% of the teams have vulnerable code in their orgs or their products. And this clearly indicates that even if you are an expert, tend to work with expert team that have they give a high importance to security. Security remains hard. We believe that these numbers are conservative, but if we look at some of the problems we see, for example, the CRUD and FLS violation, this is something that Aaron has touched upon, the importance of making sure that code will check for the appropriate user permission. So this is a Salesforce specific vulnerability, bypassing those permissions. And we find it in more than one every 3 applications built on this platform or orgs. And the implication is that the data permission that you might set with your Salesforce admin can be in fact bypassed completely by the code. Another example is cross-site scripting. This is a common web vulnerability. It's nothing that is particularly specific to Salesforce. It exists wherever web interaction exists. So we find this in 1 every 4 orgs. And the implication of this is that an attacker could execute malicious code on behalf of a trusted user. Another example is SQL injection. Is one of the one we find very often is 1 every 5, give or take. Orgs has this problem in their code. The implication of this that an attacker could hijack a custom-built functionality, a customization in your org or in your community to access data they are not supposed to see. So again, this is something that is potentially could have a catastrophic impact in the form of a data leak, for example, especially if you have external users or partners accessing your implementation. These are just a few examples, but from our perspective, this is very common stuff. And it's not because the content out there is not good, it's because security is inherently is a difficult topic, even for the most experienced teams and the most experienced developer. So it's the data that we have shows that in fact this is a something that teams should be looking at more closely. Next slide, please. If we think about Cameron earlier showed us Salesforce then and now, and if we look at the developer tooling, of course we see the same trend. The platform has evolved significantly over time, even in terms of developer tools. So we started in the days with Apex and Visualforce, and the stack today is much richer. We have Aura, Lightning Web Components, we have Salesforce DX, Scratchworks, flows that have significantly changed what non-low-code development can do, but also exciting new stuff that has been announced just yesterday. We have Salesforce functions that are bringing serverless to Salesforce, and with that potentially vulnerable Java libraries. These are all exciting new things. These are all exciting new tools that we can use to build richer experiences. But when it comes to SaaS security, we kind of see that this can lead to a little bit of a double standard. Brandon, do you want to maybe comment on that? Does this reflect your experience as well?
This is a topic that's very near and dear to my heart. Cameron, if we could do the next slide. So I've been in application security for the past 20 years. And when we look at web applications, that we are developing from scratch in-house, Ruby, Python, C#, PHP, whatever you're developing your web application in, we have so much, support from security and automation around code analyzers, vulnerability scanners for our app servers, security guidelines and best practices, whether it's the OWASP top 10 or standards or industry regulations, or the security team giving developers specific guidelines on how to write secure code and how to test. We have web application firewalls. We have runtime protection. So we've invested in all these areas in classic web application development for what our IT department is doing in the apps we're developing ourselves. But if we look at SaaS application security, the strategy up until now has really been hope for the best, or maybe hope that it's someone else's job. But we have not invested in securing these platforms. But the truth is, SaaS applications like Salesforce are mission critical. Turn Salesforce off and see how long it takes for your phone to ring. It's going to take less than 60 seconds before someone in the organization notices that they can't in and do what they need. These applications are absolutely mission critical. And the data that's inside them, it's some of the most sensitive data in any enterprise. It's your customers. It's information about your sales team and your financial performance as a company. So you have a mission critical application with mission critical data. But the security team or the IT team, we haven't invested in the same types of tools to give us that automated, scalable code analysis, vulnerability assessment, understanding permissions and config drift. So we're not enabling that area of the business that has one of the most important and largest tasks. So I think that we need to think about SaaS application security just like any other type of application. It runs custom code. It has APIs, we're building on it, we're integrating it, we're doing custom development, we're having consultants and contractors help us with development and building these applications. It's not different, but we have a double standard in how the security team engages. And what we need to do is think about SaaS applications, not as second-class citizens in the enterprise, but truly as first-class citizens, as mission-critical applications, and we need to invest that way. I'll kick it back to you though, Lorenzo. This is a topic that's very near and dear to my heart. We need to be thinking about these mission critical applications and the customer data that's inside them.
Couldn't agree more, of course, with that. And if we look at the next slide, we start thinking about, okay, what can we do to fix this thing? And what is that we can do to get things right? So the key ideas behind what I'm discussing now is called the shift left model. The key idea is that, well, in the past, all the quality assurance tasks, including security validation or security review, used to happen before or right after release. The problem with that is that these will typically halt developments for a few days, sometimes even weeks. Of course, there is a significant delay in the velocity of the business in delivering innovation, and no one really wants that, right? And we are all fan of agility and high velocity environments. And at the core of this idea of DevOps or DevSecOps, if we want to include security, is that the idea of shifting left. So moving all these validation tasks as close as possible to the point of development on the left. And of course, in order to do that, you need tools, and not only you need tools that work reliably, because automation, as long as it's reliable, can make this validation continuous and repeatable and gradually remove the burden of this from your team, your human developers, architects, security people, and leverage technology aggressively to make sure that this can be done continuously as opposed to one-off before going live with some changes. And so making this validation continuous and repeatable is really the golden standard to maximize throughput and velocity. And if we look at implementing this, Cameron, can we please go to the next slide? Well, I would like to share a little bit of my experience as an architect. So working as a CTA, my job has always been to advise customers and set in a way the best possible technology foundation for their digital transformation journey. That's in that context, shifting left is always the obvious thing to do. And Salesforce goes a long way to provide ways to do it, tooling available out of the box as part of their standard developers tools or org tools that are better than what most vendors do. This is absolutely true. But on the other hand, as the expert, we really need to look at the reality of things. And when we find gaps or barriers to adoption, it's our job to figure out how to deal with them, how to address them, for our customers. And if you look at adding security to your DevOps pipeline, to your development lifecycle, and you look at the available tooling, you will find some problems, some very significant gaps. Like, for example, if we look at the capability around static application security scanning, the code analysis for the purpose of security, existing static tools exist. So Salesforce does provide some tools, but they are either highly inaccurate and noisy, with like 70% or plus false positives, or in some cases, you cannot even embed them in your pipeline. But even just looking at the false positive problems, as an architect, not only this is disappointing, is almost a complete showstopper, because you know already that will not work. The team will not embrace it. The developers will not embrace it. It will be just noise and an annoyance to them. We don't have to look at the accuracy necessary. You can even look at the other capabilities like configuration scanning. There isn't an easy way to validate configuration against your company policies. So you might have the Salesforce health check that provides some sort of configuration checks, but again, nothing you can really add to your developer pipeline, nothing you can really use to automate, and not really something that you can use to, that's the notion of a policy that you can use to perform repeated automated checks. And another example is if you look at the data access security. So how can I make sure that the code handles data privacy correctly? It's not really something that is easy to do. So if you are, as an architect, looking at this, solving this problem, you will have a hard time. In my experience, these gaps are just too significant. No team can adopt these tools successfully at the enterprise scales without massive repercussions on either their velocity or the quality of their output. And this is why I decided to start Clayton personally. So my experience as an architect was pretty much this. The situation, the tools have evolved slightly, but the gaps have been there for quite some time. And I wanted a modern, automated, and reliable way to automate secure development on Salesforce. So Cameron, can we look at the next slide, please? I will not go into much of the details today, but just to mention that we focus on this because this is, as an architect, the tool that I wanted for my team. I decided to go and start it. So if you're interested, of course, in learning more about us, or if you're interested in adding secure development to your pipeline, you can check us out on our website at clayton.com, or you probably find in the event a link to our website. Get in touch if this is something that is a challenge you're facing. I think we can move to the next slide. I'll hand it over to Brandon, actually.
Thanks so much, Lorenzo. I want to talk just briefly about how AppOmni automates security. So what we do for Salesforce and other cloud apps is we prevent security misconfigurations by being part of the dev process. One of the great things about AppOmni is that we can plug into Sandbox and dev instances, and we can scan config changes, permission changes, new applications before you commit them to production. So we need to shift security left. We need to stop making mistakes in production and then recognizing them at the next quarterly pen test, and then going back and trying to clean them up. This problem can be solved. We have technology to shift this problem left and catch these things before they get into production and eliminate them as part of the dev the dev cycle, and the release process. So preventing data leaks, critical misconfigurations, and having the system tell you, here's what you just did. The impact is these data records are going to be exposed to 9,000 external community users. Is that what you meant to do? And the chances are the admin did not intend to do that. We're in 1% of cases are we seeing insider threat being a factor. 99% of the time, it's good people with good intentions that are not trying to make security problems for their business or their customers. We also look at supply chain and third-party risk. As Aaron talked about earlier, most organizations have no idea how many third-party apps, API integrations, and connected apps have direct live access to their production environments. AppOmni can tell you that in minutes. We can also show you which ones are being used, which ones are being exposed externally, which ones have been provisioned to contractors, consultants, external users, or the outside world. And then as Lorenzo's been talking about with SDLC, you need to be able to automate this. This is not a problem for humans. The fact that we don't have tooling and automation is why this problem is so prevalent and why we're seeing so many breaches and security challenges in this space is because we've asked people to be perfect. We haven't given them tools. We just said, we need you to make 0 mistakes at your job. And by the way, you have a really hard job, enable the entire business for remote work during a pandemic. But we're not going to give you the security tools that you need to automate it and make sure that you're not making these making changes in haste that are causing problems. And then lastly, monitoring and detection. This is not a once a year or once a quarter problem. These are mission critical applications all day, every day. If you don't have continuous monitoring, who's logging into your environment? What security data are we seeing? Are we seeing events that are suspicious? Are we seeing brute force attempts? Are we seeing changes that shouldn't occur? Are we seeing admins accidentally or intentionally disable critical security controls in our various environments? Can you give me a 360-degree view of all of my Salesforce orgs and integrate that into my detection and monitoring workflow? Well, AppOmni is the easy button for that. We do that out of the box. And as I said, we offer a 1-hour risk assessment. So if you just want to get an idea of what is the current security posture and do you have vulnerabilities in your Salesforce environment, come to appomni.com. We offer a free 1-hour risk assessment. And I promise you, it really is that fast, start to finish. Next slide, please. All right, that's going to leave us to Q&A. I see a lot of questions here. Cameron, could you read us a couple of the questions for the group for Q&A?
Yeah, let me get to that now. Okay, so first question is for you, Aaron. Is your recent release paper relevant to the shift left model that has been discussed today? If so, how? And that's from an anonymous attendee.
Yeah, well, excellent question. And just for those of you who may not be aware of the paper, I'm just give you a brief overview of what it is. So it's available on our website under the white paper section of resources. And it's a treatise on Apex security in relation to Lightning components. So briefly touched on it within the slides themselves already. But the paper looks at auditing custom Lightning components from a security perspective. And it's really the missing piece of the jigsaw in relation to my previous article discussing how permission drift within Salesforce can lead to exploitable vulnerabilities. So initially, the paper just walks through the Lightning architecture, explaining how you can utilize free and readily available tools like Burp Suite and web browser to begin dissecting these components unauthenticated and call them. And then lastly, I introduced the example vulnerable Apex code with the exact kinds of vulnerabilities that Lorenzo touched upon. So missing access control checks, socket injection, and even blind socket injection. And the great thing about the paper is that I've created a Salesforce development instance with some CTF style labs with the purpose of providing people with the ability to practice all the techniques that I'm throwing at you in the paper. So in relation to the question, yes, I definitely feel it's relevant. Ultimately what I'm trying to achieve in the paper by explaining this information is to gradually bring the reader from a novice with a basic understanding of Salesforce and Apex to someone who's confident with blindly interacting with components to find vulnerabilities in the underlying Apex. So it naturally comes across as a more offensive piece, but at the bottom line, it's also about educating Salesforce administrators and Blue Team that this is possible. These techniques and vectors of attack are real, and you should most definitely begin introducing SCA as early in your pipeline as possible, and then also leverage tools like AppOmni that provide you with a clear insight into who has access to this apex. So yeah, absolutely, it is most definitely relevant.
Okay, great. Hope that answers the question. Okay, the next question I've got up is again from Anonymous. So who typically owns Salesforce security in large enterprise? Do you anticipate this will always be a joint effort across multiple teams?
I've got an answer for that one. I've talked to many Salesforce customers. I was at Salesforce for 10 years, and I was on the receiving end of most customer security audits. What my experience has been is most organizations, when they bring in Salesforce, they bring in external consultants, or they have their own in-house security team, and they do a penetration test. But they're testing the security of the Salesforce cloud as a service provider. And I will tell you firsthand, Salesforce does an excellent job of securing their cloud infrastructure. They harden their perimeter, they harden their infrastructure. That's not the weak point, but usually that's where most businesses stop when it comes to securing SaaS. We're going to scan the perimeter, we're going to hire some pen testers, and if they can't break into the Salesforce data center, which they can't, well, I guess there's no problems. But buying a safe car doesn't mean you know how to drive it. It doesn't grant you a driver's license. So the Salesforce service can be secure, but oftentimes the security team is not engaging once that's been deployed. Now all the data's in it. Now that all the users are in it, what is our risk? What does our configuration look like? And the security team and the Salesforce team are often not interacting there. So I think it is a team sport. I don't think that you can give IT and the Salesforce COE full control of the environment and then hand it off to the security team to secure it. It has to be back and forth. There has to be collaboration. Yeah. And part of it is the security team telling the IT team and the Salesforce COE, here's what good looks like. Here's the best practices and the tools that we're giving you to ensure that you're doing your job quickly and securely. Lorenzo, I don't know if there's anything that you want to add on how you see ownership, but I often see that it is a team sport, but the teams aren't talking.
No, I think I've nothing particular to add. I think that you covered everything very well. Cameron, I don't know if you see things from your perspective. Is there anything that you see differently when helping customers navigate security?
Yeah, I completely agree. It's a team sport. I think one of the key things I'd say with large projects is getting in early with the security team and getting them skilled up. To their, to respect to them, like, they obviously probably don't have the same Salesforce background as your Salesforce COE, obviously, but they need to be lockstep with you with regard to how they secure that, because it does become partly responsible of their organization. So yeah, where I've seen successful, rather than bringing the security in right at the end of a project, is also shift like that as well, right? Like have that as a topic on the table early on, so that they're not coming in with lots of red flags and questions, and they're quite flustered trying to figure out, well, what are you doing? Like, how can you do this? What's the classification of the data? Those types of things. By the time you get to like your release day, they've come along for the journey. They've skilled up as well, because ultimately they're going to own parts of the BAU as well, right? So yeah, definitely agree. It's part of a team sport. Okay, let's jump to another question. Do we have any metrics on impact of automating configuration, data access, and code security testing for SaaS applications like Salesforce? How much faster can a typical COE push out releases relative to manual testing?
Well, I think I can answer a part of this. Go ahead, Lorenzo. Oh, sorry. No, I just wanted to. I think this is something we can probably address from multiple angles. I think that when it comes to data related to metrics related to how code scanning can help, one of the things that we do at Clayton, we help you set some security policies that, of course, would include compliance with against vulnerabilities or third-party vulnerable libraries, or whatever the translation of best practices and not having vulnerabilities is for your to your security policies. We can check that, and one of the things that we check is also the degree of compliance over a period of time. So what we see is that if we start a sprint or an iteration or working on a release, we can tell you on average how many problems violations to those policies have been introduced and how many of them were fixed early by the team. So we can give you an indication of the compliance level of your change by looking at the deviation from your company security policies. And of course, this is a very powerful metric because it tells you very quickly, okay, I have a business change, I have a release train that is going live and is delivering this value to the business. And I also know that I can tell the security stakeholder, this is our degree of compliance with industry best practice or security best practice or vulnerability, I would say vulnerability risk point of view. So one thing is that we can do is we can measure that. The other thing that, the side of the answer related to how we measure velocity and impact, this is harder to estimate because there is, as you correctly mentioned, there is a change-related velocity difference, and that is not something that, as a tool, we can simply measure. One of the things that we measure is how much of the manual effort we can remove, and just by doing that automation, by introducing automation that frees up the developer and the technical team, so it's no longer their burden, we see a average 20 to 30% increase. It's not, I wouldn't say is increasing the speed of the delivering a change, but it's definitely a gaining capacity. So that is something that I can tell you from the data that we have and my experience to answer part of your question, but probably Brendan has something that he can share as well from the data that I see.
Thank you so much. I'll keep it quick because we talked a lot about security, but there's functional testing and a lot of workflow that we also have in the AppOmni platform that we don't have time to dig into here, but we have seen organizations on average moving between 200 and 400% faster with their deployment cadence in Salesforce after implementing AppOmni. That's not a typo. So 2x faster to 4x faster. We have a customer that went from releasing Salesforce releases once every 2 weeks to releasing at least twice weekly, because we've automated testing, we've automated config testing, we've automated data access testing, we've automated the ability to see what's the difference between these two orgs, the ability to look at different users or configurations and find what's different or why it's working for this user but not that other user. So the performance benefits and the ability for the COE or IT to move faster are almost immediate. And we have a lot of data of enterprise customers that are moving significantly faster once they put this automation. And it makes sense. It's a lot easier to have the computer check 100 places for something than for a human to remember or try and go through it manually. You get so much more leverage out of your team when you give them the right tools, when you undo that double standard and you invest in security and IT for SaaS applications like we have in other areas of the business. The results speak for themselves.
Okay, great. The only thing I'd add to there as well is that the further you get into your dev cycle, the further you have to go back when you find issues, right? So I think we've all been there maybe early in our careers where you're going to deploy something and you found there's some vulnerability, or it's Sonar or Clayton or whatever kind of static tool analysis you're using currently. It's kind of giving you an error, and then you've had to go back and fix it. If you're running these more regularly and it's kind of built into your process, then you're going to see much more throughput from your developers. Okay, so moving to the next question from Francis. The slide mentions CLI, Force.com, Scanner, and Health Check, but doesn't include Optimizer, or is that Health Check? I think that was Lorenzo. That was one of your slides.
Yeah, sorry. Yeah, no, it's a good point. We wanted to provide a summary that was kind of a balance between showing everything that is out there. And of course, we had to make some simplifications. The health check we refer to is the health check, so not the optimizer, but it's something that we did for simplicity and for providing a kind of a high-level summary. Of course, there are other tools, other options available. You can also kind of mix and match by going a little bit in the custom scripting world, but yeah, no. So it's a health check that we meant.
Yeah.
So fun fact,
yeah.
I'm actually the original author of Salesforce Security Health Check. I wrote the first version of that back in 2008 and maintained it for several years. Optimizer is different. Optimizer does have a couple of security features, but more is looking at license management, inefficiencies, and that's a separate tool. But to Lorenzo's point, there's a lot that's in the ecosystem here, but we showed the 3 biggest tools by default.
Yeah, I was just going to add to that is that I think the key takeaway from this here is that some customers we see that they say, well, we're secure because we run health check and we're using Force.com scanner, right? But yeah, they're not even aware sometimes of what those tools are actually doing. And as I mentioned earlier on, is that not all tools are built the same. So the breadth of the language and the number of rule sets they go through is not necessarily on parity. So the key thing is when your strategy is think about what are the specific tools that you need and make sure that they're servicing the requirements that you have as well. Okay, question from Brian. Is there any documentation available on how to use managed packages to effectively secure secrets? So I think, Aaron, that's for you.
Yeah, and I'll just briefly mention that unfortunately there isn't really any extensive documentation. I know one of the Salesforce Trailhead modules does briefly touch on it, but to kind of just boil it down for you, I'm not sure if you have any Salesforce development experience, but typically how it works is you would have a separate Salesforce org with the development settings of the organization set to be able to create a managed package. Once you create a managed package, you can then declare a custom setting as normal within your organization. It must be set as protected in order to get that namespace kind of separation. And then once you have done that, when you go into the package manager of your org, you should see a custom setting as a selectable component type. Just select the custom setting, click add to package, and then you're effectively done. Now, naturally, you're going to want some way to interface with that custom setting in your actual production org. So this can be a global Apex controller with a Visualforce page attached to it potentially. So that when you do install that managed package within your production org, someone like a system administrator or extremely high privileged user can interface with that Visualforce page in order to store and retrieve the custom setting within the managed package. But that being said, please also take into account that if you give anyone access to that underlying Apex in the managed package on that Visualforce page, then it's effectively, it's redundant because it's going to be accessible to anyone who has that access and also anyone who has the view all custom settings system permission or explicit access. Yeah, so unfortunately, I can't give you a full walkthrough here, but hopefully that kind of cleared it up a little bit.
Great, excellent. Thanks, Aaron, for that. Guys, I think we're at time now. There's a few more questions. What I was going to suggest is that we're obviously recorded this session. We're going to distribute this out and we'll also send out our email addresses as well. So any of the questions we didn't get around to today, or if there's any additional ones that kind of come up between now and then, feel free to send them over. But yeah, thanks everyone for first of all dialing in and listening us walk through a pretty dense presentation on some pretty important topics. And also, thanks for Lorenzo, Brendan, and Aaron for contributing as well. I think it's been an interesting session to be involved with.
A big thank you to you, Cameron, and the Accenture team. You guys are fantastic.
Thank you. Thank you
Awesome.
Very much for being here.
Awesome. Okay. Cheers, guys. Thanks very much. Bye.
Thank you. Bye.
Thanks a lot. Bye-bye.
Have a good evening.